now we're into math. Panic! Math! Ah!
Just teach me how to do math.
From the ground up.
Okay. Maybe I can catch
So,
up.
something just for you guys that are looking at doing this more as a career. I've noticed a shift over the last couple of years that more and more of my clients are coming in at like 7, 8 years old, and I didn't see that 3 years ago.
It's because they're pushing our kids to do so much.
Yeah, I think so. There's been a shift.
We want you college ready.
There's been a shift. Yeah, by the first grade.
Yeah.
You know, I mean, I had a kid come in last year, and he was like in 2nd grade, and the math problem that they brought in was if John's mother has already canned 3 cans of peaches, and she's going to can 6 more cans of peaches, and she cans 45 peaches, how many peaches in each can? This is was like a 2nd or 3rd grade problem, and I of course I know what that is, okay, mathematically. Now I'm not sure how they're expected to solve that. Some kind of process of elimination, or they're supposed to do it. But look at what this is. This is x equals 3 plus 6. Okay? Y equals x divided by 45. That's the mathematical solution to that. So you solve for x, okay? So that x equals 9, and then y is equal to 9 minus 45, and y equals 5. That's crazy.
Yes.
I mean, I just can't get over that. How they would expect. Now, yes, can you intuitively deduct, play games, and get that answer? Yes. Is that math? No. It's not even close to math. It's not even in the same universe as math. So that is a particular problem for some of these kids who may even excel in math. But you would never know it if they're getting problems like this.
Well, especially with all those words in between, that's where they really just start, what am I reading? What do they want? What, you know?
So yes, if they're having reading problems, that's a big factor in math. So, okay, so let's start. Math facts. Most math facts are brought to kids as an auditory process. Okay? Flashcards, typical flashcard that, that says, here's your flashcard. Let's get rid of this. So your typical flashcard looks like this. And 9 times 5 equals 45. I'm bored just writing it. Okay? So notice that you have 5 separate symbols. There's nothing real in that card. There's 5 separate symbols. And if you can really identify visually or auditorily with those symbols, and you can remember to process them in exactly the same order, okay, in your brain, this card may be of some value to you. But after you look at 20 of those, I really doubt, for some kids, the value of that. Okay? Some kids it works fine. Other kids, I don't see it. I don't see it working. So, one of the things that we want to do is first get back to a place where the child can make a real world connection to math. Okay? And that's going to be different for everyone. For some kids this year, I was saying some of these young kids, it's literally, we can go to the next page. I literally start out with blocks. And 1 plus 1 is 2. 2 plus 1 is 3. 3 plus 1 is 4. 4 plus 1 is 5. 5 minus 1, okay? And we may start out just going even simpler. I may take out a yardstick. And I'll put this block here, which happens to be 1 inch, so it works out really well. But it could be anything. 1, 2, 3, 4, 5. This is 5 blocks. 3 blocks. 4 blocks. 5 blocks.
So is the yardstick helpful because they can see the numbers right in front of them as
This
well
starts connecting the number to the real physical thing. So it's bringing their real world experience, connecting it to the abstract, these number thingies. And so that's what that page is about, just kind of my best visual representation of playing this little game. And then it'll move on, you know, like I said, after we do some counting, you know, it'll be, okay, 5. 5 minus 1, 4. 4 plus 1, 5. 5 minus 2, 3. 3 plus 2, 5. And I think, like I mentioned, I had some kids that would go 5 minus 2, 3. 3 plus 2. And they'd stop, and they literally had to count. 1, 2, 3, 4, 5. And I was like, okay, I'm worried. Because we did it like 20 times in 10 minutes. Just right here. And it was like every time I went like this or like this, he'd get 2, 3, 1, 2, 3, 4, 5. He couldn't get that there was 5 there. So we kept doing the cross crawls, we kept doing his exercises. By the end of probably almost 3 months, he was up to 10. And he kind of had a pretty good grasp of 10. And he was getting pretty good at 10. Once we went over 10, 5, 10, 15. Yeah. 10. 5, 10, 15, 20. It was really a struggle. He was just in that automatic mode.
Because you made a pattern of doing 5, so he just kept going.
He see the pattern, boom, just go right with it. So we really had to work on this. And what I noticed was over the summertime, we did some serious work, like an hour, 2 hours a day on his cross crawls and his focusing. And relaxing and focusing, relax and focus, relax and focus. And he was able to get it. And he's the little guy. We got up to grouping. We started grouping tens. And we made up a new number, because the teens were really confusing. So we made up a new number system that was called 10D1, 10D2, 10D3, 10D4. And it was kind of kind of like a little inside joke that we had our own number system, but it definitely helped. And then but it really, the concept of grouping into tens and taking a 10 away and adding a 10 and adding groups of tens plus, literally understanding that this number here is groups of 10, and this is groups of 1. So we had to really go over what do we mean by a group? Because he didn't understand that. Okay, so this is a group of 1, 2 groups of 1, 3 groups of 1, 4 groups of 1. Okay? And then blah, blah, blah. This is a group of 2. And now we have 2 groups of 2. Or 2, you could say 2 times 2, or 2 plus 2. And then we had 3 groups of 2, or 2 plus 2 plus 2, or 3 times 2. And each of these is a group. And then we got to 4 groups and 5 groups. And it's pretty cool because it doesn't take too long before we get to something like 1 times 3, 2 times 3, 6. 3 times 3, 9. 9 divided into 3 groups. Okay? Now how can you miss that the first time? You see? How can you miss that? So I have 9 divided into 3 groups. What do I have? 3. Yeah, awesome. And 3 times 3 is 9. And 3 times 4. They'll always have to count this the first time. Okay? And sometimes I'll go not 3 times 3, and then 4, so they can see it moving together. They have this visual, tactile experience. So 3 times 4 is 12. 12 divided by 4 is 3. And then 3 times 4 is 12. And sometimes I'll do 12 divided by 2. Ooh, 6. 6 divided by 2, 3. 3 times 2, 6. 6 times 2 is 12. 3 times 3, 3 times 2, 3 times 0. And I just go, oh, you got me. Because I try to trick them, you know. But see, if you're just sitting in class and it's well, it's 3 times 0. Huh? 3, 0. Hell if I know. But if I go 3 times 0,
That always
it's
confused
0.
me as a
There's
kid.
nothing left. You know, our 6-year-old knows that. Or he's not 6 anymore, but he did know that. So anyway, these are really handy. And it's amazing how fast kids that really, really struggled on and on and on for an entire year of math, how fast they will go from counting to 5 to, you know, you looked at that test that he had. It was a time test, 50 problems, addition and subtraction. He got a 50 out of 50 on it. You know, a little guy, Jacob. It was unbelievable. His dad looked at that and he goes, whoa. He hadn't seen it yet. So, once we start having the concept of counting, of grouping, now we're able to start getting into our math facts. What I like to do is use blocks, cards, just plain playing cards, and dice to learn addition and subtraction, basic addition and subtraction up to 10. Okay? That's my magic number, 10. I'm not interested in going over 10 right now. 10. So I will flip over cards and manipulate them so that the numbers stay pretty close to 10 or below. I will let them play with the dice. And a game we play is maybe for young kids starting out with 2 dice and then 3 dice and then 4 dice. And then go up to about, 10 or 12 dice. And I have them roll them out and make 10s as fast as they can. 5 and 5 is 10. I see the pattern. Once I do that 50 times, I'm going to see that pattern. And 6 and 2 and 2 is 10. And 6 and 3 and 1 is 10. And 5 and 5 is 10. And now I have these left over. And you just do that. And this is a nice game. We throw this into our homework between the reading and the math. We usually throw in 2 minutes of math games. As they, and never mind the cards. Let's stay with the dice for now. So I focus on building up their little skills with the cards and the dice. A lot of adding 1, subtracting 1, adding 2, subtracting 2. So what I will often do, actually I do have a way with cards. So let's say we're gonna practice adding 2s. Okay? So I'll just take 2 and I'll say 8 plus 2. 7 plus 2. 3 plus 2. 5 plus 2. 6 plus 2. Okay? And then we'll do minus 2s. And then we'll do, 6 minus 2. 8 minus 2. 7 minus 2. 5 minus 2. So I'm really gonna drill in these little adding and subtracting, probably up to about 5. But mostly 1, 2, and 3. Mostly 1, 2, and 3. I'm really interested in those. And then for the bigger numbers, and this is going to be for young kids, not so much for your kids.
Yeah.
For younger kids, for the bigger numbers over 10, what I'm going to do is teach them how to add and subtract using complements. And it's going to sound complicated, but it's funny because the kids will always pick it up faster than the parents do. So let's say I have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Oh. Not to be obscure, 10. So I have 10. 10 is the magic number. And if I take 1 away from 10, what do I have? I have 9 and I have 1. Okay? Now, let's say I want to add 9. Okay? It's a big number, kind of confusing. So let's say I just want to say 9 plus 2. If I take 1 away from the 2 to turn the 9 into a 10, I have 1 plus 10. 11. Pretty easy, right? Most kids can add and subtract 10. Okay, let's do it again. What if I have 9 plus 3? I take 1 away from the 3 to turn the 9 into a 10. 2 plus 10 is?
12.
Or 10-2.
Okay.
If I have 4, 4 plus 9, I want to add 9 to 4. I take 1 away to make this a 10. I have 3 plus 10 is?
10d3.
10-3.
Okay.
Pretty easy, right? So you take something that's a little complicated, you break it down into 2 simple steps, and it's very, very easy for kids to grasp that. Now let's do 8s. Let's say I have 8 plus 2 is?
10.
And 10 minus 2 is?
8.
And what if I have, let's jump up, I have 4, and I want to add 8 to it. So I take 2 away from the 4 to turn that 8 into a 10, and then I have 2 plus 10 is 12.
So,
Awesome.
when you're working with the kids, you do it just like that. Do the kids catch on to where they just see the blue and they know the blue with the other blue makes the 10 and they just add the other color? Or do you always move it back over to make the 10?
Always move it back over at
Okay.
this level.
Okay.
Always move, I show them,
Okay.
boom. And sometimes even with the cards, you know, I'll say 8 plus 7, and then I'll go like this. So let's take 2 from the 7 and turn the 8 into a 10.
Okay.
So minus 2 plus 10. Minus 2 plus 10. And they'll go through the deck like this after a couple of minutes. Literally that fast. And when we start doing multiplication, so anyway, no, don't only jump ahead. So that's a really good way to get our addition and subtraction down really fast. Faster than any other way I know of. Okay, and that's page 79. It's also talking about, you know, using the complements of 10. So memorization of math facts, the times tables. I already started showing you this, that we use colors and groups to start to show 1 times 2 times 1, 2 times 2, 2 times 3, 6 divided by 3, 2 times 0.
Do you have a good way of teaching carrying and borrowing?
Yeah, yeah. Or as they now say,
They do call something.
Regrouping.
regrouping.
Yeah, doesn't it kill you when your kids come out with these new words? You're like, what? I don't know what we're doing, and you have to like look at all the pictures. Oh, we're just doing regular math. It's like.
Oh yeah. Well, also, here's something for everybody. This is gold for younger kids. It's your math vocabulary.
Yeah. They come home with so many new words now.
And this is, I'm sure, subject to change, but it's a pretty good list. Okay, so So regrouping. So now we're back to showing that we have 10. So we have these groups of 10, and then on the other side we have these groups of 10, and then we have this 1, these groups of 1. So with the blocks, I can pretty easily show 6. So let's do this. Recipe here. So I have 2 groups of 10, which is 20, right? And then I add, let's say, 3 more over here in the 1's place. So I have the 10s and the 1's, 23. But what if I want to take away 5, which would look like 23 minus 5. Okay? Well, now I see I can't take 5 away from 3. It doesn't work. So I have to borrow or take away or regroup. And what do? Is I take this 10 over from here and I move it back over to here temporarily. So now in the 1's column, I have 13 instead of 3. Because I took all these 10, because these are 10s, so I took one of the 10s, moved it over here to get 13, and now, look, I can take the 5 away, and I have 8 left. Does that make sense?
Yeah, that really would have helped me when I was a kid. I struggled so hard in math, it was just so awful. And
it's amazing how fast they go abstract, even with
Yeah.
money and stuff. I'll talk about money too. But they get way too abstract.
They put in variables in what, 4th grade, 3rd grade.
Yeah,
like solve for the empty box. It's like, what is that?
yeah. And they're just trying to prep them for what's coming. That's always their goal. Oh, we're just preparing you, and really you're just making them more confused. Just let them come to it
and
when
there's
it
no
comes.
evidence. There's no evidence to
No.
suggest
That it
all this
helps.
early stuff helps at all. In fact, again, I don't push Waldorf. But when you look at the way they put off learning certain skills,
Yeah.
the education accelerates as they get older. Whereas the other kids, they start here in the 1st grade, but then they actually go slower.
Right.
And if you look at the way the Waldorf kids go into high school, they're way more prepared. Way more prepared. And the way they go into college, like you look at the acceptance rate for SAC Waldorf. I mean, the colleges that accept them is, it's amazing. The number of students that get accepted by university. Isn't there only one other college in like California that has a higher?
You mean high school?
One other high school that has like a higher acceptance.
It's like, I think it's like Jesuit or
Yeah, it was
something
like
that.
Jesuit. Okay, so you can spend like $14,000 a year to get a higher average acceptance to universities than the Waldorf. Of course, the Waldorf isn't cheap either, but anyway. And I can't speak to the model of education that Jesuit uses. I'm not really familiar with it.
It's a very academic
Yeah,
focus.
probably. Anyway, there's just a lot of evidence to suggest that earlier is not better.
Yeah, it just frustrates them and overwhelms them, and then they kind of give up and don't want to move on. And
Right.
just, yeah.
Well,
Right.
and they've shown that by ignoring the imagination in the early grades and kindergarten, by
Yeah.
just ignoring that, it affects their reading and stuff later, because it's your imagination and building those pictures
Right.
that allows
Right.
you to utilize the information. So there's this crossing point that when you get to school where they stop wanting you to repeat it back to them, and they now want you to actually take meaning from it and use it, and that's where it breaks down.
Right.
So if your imagination was encouraged and you had strong imagination skills when you were younger, those are now the skills that you're using to hold that information that allows you to be able to use it later, and that's what's missing in our education system right
Yeah. Okay. So yeah, with blocks, you can really, I mean, I can show a 5-year-old multiplication. And they'll actually get it because it's with the real things in the real world. It's just, you know, one group of 2 plus another group of 2, which, you know, is 2 plus 2. You can do that.
Right.
But is it faster to just say 2 times 2? Or I could say, you know, 2 plus 2 plus 2, or 3 times 2.
Right.
And if I want to take them apart real fast, I just say 3 or 6 divided by 3. Anyway, and then we go on to so all the way from, let's go to page 81. From 1 times 1 to 6 times 6. See the green ones, that little box right there? From 1 times 1 to 6 times 6, we practice skip counting with our hands. And there's lots of ways to do this. We can do it with the blocks. We can do it with our hands. 1, 2, 3, 4, 5. 2, 4, 6, 8, 10. 3, 6, 9, 15, 20. Or 8, what did I say? 18. 4, 12. Or 4, 8, 12, 16, 20. And then 5, 10, 15, 20, 25. And then 6, 12, 18, 24, 30. And one more makes 36. So there's a couple of games we play with that. The skip counting. I have a little thing I do on the next page where I take an 8.5 by 11, and this is my math facts card. And I like these. And you only do 1 or 2 of these at a time. They work. I think they work really well. So you can take any 2 colors. If the child is young, I will use. I will start by using red and blue for addition and subtraction facts, and then I will switch colors to like orange and green for multiplication and division. I don't use the same color. But if he's older, I'll just use red and green. So I'll make a red triangle, and I'll just say 8 times 7 is 56. And then we do it just like a spelling word. Hold it up to the left, and I have him read it off. 8 times 7 is 56. 56 divided by 7 is 8. Backwards. 7 times 8 is 56, and 56 divided by 8 is 7. Okay? Close your eyes. 8 times 7 is 56. 56 divided by 7 is 8. 7 times 8 is 56, and 56 divided by 8 is 7. You review that within an hour, a day, and a week. Do only a couple of these at a time, and they'll have them down cold. Absolutely cold. And if you look at the chart again, back to the chart, you'll notice that the ones times tables, they're in green. They're easy. 1 times 5, 1 times 6, 1 times 7. You'll notice that the 2s are pretty easy. Most kids really quickly count by 2s. 2, 4, 6, 8. Who do we appreciate? And then the 5s. The 5s are pretty easy. 5, 10, 15, 20, 25, 30. So if you look in that first group, there's probably only about 4 or 5 facts that are actually going to be any kind of a challenge. A little something else I do is I love to work with the squares. So I show them with the blocks, and then with the other with my a little fast there. So I would start by showing them a block of 6 times 6 with blocks, and then I'd also do the math fact like this, using a square instead of a triangle for the few squares, maybe 4 times 4 and 6 times 6. And very quickly, I'll bet if you get ahead of the schools, you can probably teach a kid their math facts 1 through 6 in about a month. or less, a couple of weeks, they'll have these down cold, really solid. Then we go on to the 7, 8, and 9. And those, we're going to use our awesome, for almost all visuals, our awesome pattern recognition skills. Okay? Yeah.
Do you know the 9 trick? Do you teach them that? Do you know what I'm talking about?
I have more 9 tricks than you can shake a stick at. The finger trick?
No.
9 times 2 is 18.
No.
Or let me do it backwards. 9 times 3. 9 times 3, you hide the 3. 1, 2, 3, and it's 27.
Okay. It's similar to that. Mine's whatever you're multiplying, like on the board, you're multiplying it by 5. So 1 less than 5 is 4.
Well, yeah, and here's the way I show them that.
Okay.
So 5 times 10 equals 50.
Right.
If I do 5 times 9, 9 is 1 less than 10,
Right.
right? So it can't be 50, it has to be a little bit less, like 40, and then 4 plus what?
Makes
Plus
9.
4 plus the 5 gives me 9.
Right, but the easier for me way, and I struggled through math, was that like, okay, 9 times 3, 1 less than 3 is 2. 2 plus what makes 9?
2 plus what makes 9? There you go.
Yeah, that's what I've always did.
Yeah, that's what I meant.
Okay.
I forget what I said. Yeah, so you come up with the first number, and then that
Plus whatever
plus
makes
whatever
9.
makes 9. Yeah.
Okay.
I also show them that like 9 times 1 is 9, 18, 27, 36, 45, 54, 63, 72,
Right, reverses.
81, and then 90. So there's actually, and if you take off 9 and 90, there's only 4 numbers. There's 18, 81, 27, 72. So we play with some of those games, but mostly what I want them to see is
Picture.
well, first we do the song to get the pattern in their head. 9, 18, 27, 36, and 45. I don't know why we're on 9s. I'm looking at 7s here, but so 7 would be Mary Had a Little Lamb. 7, 14, 21, 28, 35, 42, and 49, 56, and 63. You do that half a dozen times, you got your 7s down. Now you add in with the fingers, right? So 7, 14, 21, 28, 35, 42, and 49, 56, and 63. What's 7 times 5? 7, 14, 21, 28, 30, 35. So that's the first step, not the end. It's like skip counting, okay? It's like counting on your fingers. It is not the end, it is just the very beginning. Then what I do is we take the times table, and I might have them sitting at this table or maybe at the dinner table, and I'm going to take this, I'm going to put it up on the wall so that it is where?
The left.
Up to the left. I want them looking up to the left for the answers. And now I take the cards. If the child is young enough, I might only do I might only do the bottom half, like 9 times 2, 3, 4, and 5 to start, and then I'll do the other ones. But if they're a little bit older, I'll pull it out. Where's my 9? There's my 9. And then we just start going through the deck.
Why is 45 circled?
I give them, it's a little cue. All the 5s are circled when we work together.
Okay.
The 9 times 5, the 6 times, the 7 times 5, and the 8 times 5. They're always circled, they're kind of being in the middle. 9 times 2, 18, 63, 72, whoops. 72, 72, 27, 72, 18, 54. And literally, as they go, they'll get it that fast. Now in the beginning, they're not going to get it fast. They're going to look at it, and then they're going to look up, and up to the left and get the answer. Is that cool? Look up to the left to get the answer. So I'm training them to, when they want an answer, they look up to the left. They go to those pictures in their head. So very quickly, in about a week at a time, they should be able to get their math facts really quickly. There's our math games, the dice, the cards. Okay, math concepts and formula. This is about where you're at right here, probably. The most important thing to remember with right brain students right brain thinkers is that they are outside of the box. They are outside of the conventional box. So when he looks at a problem, he's thinking of 27 different things. Mm-hmm. Does that make sense?
Oh yeah, he's tried to verbalize it to me. I'm just
yeah.
And I just nod. I'm okay.
Yeah, and he's only consciously aware of part of it.
Exactly.
So there's so much going on there. It's really amazing. So what we want to do is help him narrow down the possibilities. And unfortunately, when the teacher, I think we went through this a little bit, when the teacher explains a new concept, she's going to show him the steps. She's going to show the class how to do this. And your son, because he's bright, like most of these kids, he is not going to have a question, because it's all going to make sense to him.
He's going to finish the page by the time she stopped talking, is usually where it is.
Probably. So that's right, he's not having any trouble with math at all, really.
Well, he is in the sense that his teacher, got frustrated, he wouldn't show his work, and so she's giving it just trickled down from there to where we ended up with a D at the end of the year and hated math because of her.
Yeah.
But it's not that he didn't understand it, it's that...
Got it. Okay, so some of this won't apply directly to him. A lot of it won't. But for a typical child who's starting to struggle in math, a lot of times it's because they got too conceptual too quick in the younger grades. So he's missing some important concepts. But a lot of times it's because the teacher will explain how to do the problem by looking at the steps, how to do each step, but she doesn't explain why she's doing the steps. And without knowing the why, without being able to extrapolate the why from the how, visual thinkers are going to have too many possibilities. They're going to be lost. As soon as they come to a problem on the very next page where they can't imitate what the teacher did, they're lost. Does that make sense? Good.
That's me.
So what's really critical, and this is how you can teach moms to teach their kids when they get into Algebra 2 and geometry and all that. You look at the book. All right, here's your book, your math book. Okay, and the first thing on the top of the page in the chapter is, in almost every math book, is what? Vocabulary. If you don't understand the vocabulary, you're not getting very far. And I've had kids. Who was it? One of my big guys. It was like geometry or Algebra 2, and he came in and he was having to solve for identify which functions were symmetrical. I said, okay, so what does symmetrical mean? I don't know. Well, there's an hour of, shot to heck. He didn't know how was he going to solve the problem?
Right.
So I said, well, and here was the funny thing. In his book, it actually had at the beginning of the page, it had the word symmetrical with a page number.
Nice. Page
number, 69 or 123 or something like that. I said, well, let's go look at page 169. So we went back, we opened the book, and he was like, oh, and it showed, here's the graph, here's the graph, here's the graph. Oh, okay, I get it. And he finished his homework in like 5 minutes. So vocabulary is really important. We can't skip over that. The next thing that they're going to give us is, in most books, they're going to give you a list of 1 or 2 skills that are either required or you're going to learn for this chapter. Now, here's the thing. Math books are not random, arbitrary, and capricious, okay? Every problem in this chapter is going to use those two skills. That's it. Plus the previous knowledge. So we don't have to like go outside the box to a whole lot of inventing and whatnot. We need to know these two skills. And where are we going to find those two skills? In the very next thing on the page, which are the examples. But we need to look at our examples in a very particular way. And that is, we look at each of the steps. Now, first of all, why do we skip over the examples? Because he knows they're easy. So we skip over the examples. But why do we need to not skip over the examples? Because they're easy. This is the place, this is where the gold is lying on the surface. See, you don't have to dig for it. You just look at the example and you say, okay, wait a minute, why did you do this? Okay, why did you do that? Why did you do this and why did you do that? And you look at the problem backwards and forwards, which is what he's good at anyway, and you see why. Okay, we're done. We're done. Now skip all the easy ones. Go right to question 37 and say, okay, solve that one. Boom, done. Amazing. Amazing. And again, that was the Oompa Loompa effect that I was talking about. So if we don't understand why every problem looks different, you're reinventing the wheel, you're looking at 2 hours of math. 2 hours. If they all look alike, then you're down to 30 minutes or something. It's amazing. Because the difference between having to think through the problem at 3 to 4 words per second, you know, let's say you got 30 problems times about 10 steps in each problem, and you got to think through verbally and work through and carry the numbers. You know, let's say that's 300 steps times about 5 seconds per step. You're looking at 1,500 seconds. No wonder he doesn't want to write his work down, because he's burning up all his time with mental, cognitive, blah, 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 right? Yep. But let's get rid of that nonsense. Let's use our math facts, boom, boom, boom. We write the rest down, get it out of our heads as fast as possible, and now we have 300 steps times 1/10 of a second, or let's say 1/5 of a second, or something like that, 0.2, whatever it is, and we're looking at 60 seconds or something like that to process the same information. I mean, it's huge. It's huge. So there are mental processes that are fast and really right to the point, and there are other ones where you're going to circle around and you can watch his eyes. Mm-hmm. If he goes like this for the problem, 56, 72, 81. $49. Not efficient. Right. Not efficient. It may feel efficient because he doesn't have to write it down, but that's another thing to point out to him, that where are you really saving the time and getting the right result, the result that you want to get. So the only word you need to remember here is
why.
Why. That's it. That's the whole lesson right there. As far as memorizing math concepts and formula, it's just like abstract information. The easiest way is to make a picture out of it, and you can use mnemonics and pattern recognition. There's a lot of things you can use. There's like for the quadratic formula, which is what, x equals negative b plus or minus the square root of b squared minus 4ac all over 2a. All right, So they have there's a cute little story that goes with that, right? A negative boy couldn't decide whether to go to a party, and he met 2 boys and saw 4 cute girls or something like that. Anyway, that's a cute little story, but it doesn't explain why you need that information. It doesn't explain what to do with it. I've had kids come in here and they would try to plug in all kinds of numbers into the A, the B, and the C because they didn't understand that in order for this to have any validity at all, you have to start with ax squared plus bx plus c equals 0. You have to have the formula in that standard form. Otherwise, your answer is meaningless. Does that make sense? So why are you using this formula? Why? Why is it important? Does that make sense?
Much sense as it can make to me.
Yeah, well, but it's the why. It's the why.
Yeah.
We'll go through your whole thing, how you get from there to the x.
No, I'm not going to do that to these guys. You did. It's
And I get the why.
TMI, too much information.
Because I always asked why, and nobody ever gave me the answer to the why. But
Yeah. But you can actually get from here to here. That's what Lisa was saying. You divide everything by A.
I'm sure if you had this conversation with my son, he would totally understand what you're saying.
And then you have x squared plus u plus b over a times x plus b over 2a squared equals negative c over a, and blah blah blah, and then you get down to that formula. And if you were in high school, it would be worth walking through that, because now you see the connection. They're connected. Why? Why? We have a whole thing we do often on geometry, where everybody in the world, everybody knows the formula for the Pythagorean theorem, right? So one thing you remember from school, come on.
Nope.
Triangle. A, B, C. What's the formula?
A times B times C plus.
No.
A squared plus b squared equals c squared, right?
Does anybody remember that? At least hearing it.
I'm pretty sure my son said that to me a few
A
months ago, and I
squared
still
plus
looked at him
B
blankly.
squared equals C squared. Right?
Sounds familiar.
I mean, I remember there was a high school reunion where the guy, he went back to his geometry teacher and he walks up to him and goes, "Good to see you again. A squared plus B squared equals C squared." And the geometry teacher was like, "Wow, that's really cool. I'm surprised you remembered it." He goes, "Yeah, and this is the first chance in 10 years that I've had to use it." But here's like, you'll see this in one book. And a year later, in a totally another book, you'll see this. You'll see this formula. You'll see x1, or x2 minus x1 squared plus y2 minus y1 squared equals distance. Right? And this will be presented like, "Oh, look at this. It's a new thing." But what is it? What is it? Look, here's my little triangle. Okay? Look. A, B, right? So we have A squared, right? X2 minus X1 is A, and Y, this is B squared, and D is the hypotenuse C squared. Sorry, forgot the square. Actually, because this is always presented as the square root. Like that. But it's the same thing. It's exactly the same thing. Does that make sense? A little bit? It's not, the math is not important.
Yeah,
But do you get how this and this are exactly the same thing, but they're not presented that way. They're not presented with any kind of continuity or association. And then later on, when they start doing another 2 years out, when they start doing this, they'll get a circle, and they'll see something like this. And now they'll see this is R, and they'll say, then this is HK, and this is XY, okay? And they'll get a formula like X minus H squared plus Y minus K squared equals R squared. But guess what? Look. It's the triangle again. There's no difference. But they're going to confuse the heck out of the kids because they present this as if it's something completely new and different.
Right.
So there's, again, it goes back to that connecting information to something you already know. How does it connect to something you already know? And anytime we can help kids do that, we're doing them a big, big favor. Because to come up with an entirely new concept and find a place in our brains and store that and be able to retrieve that again is really a lot of mental power. It's a lot of mental work. But just seeing, oh, so this is another way of saying a squared plus b squared equals c squared. Well, heck, I know that. Even my mom knows that. Just kidding.
This is why my husband helps with math and I do everything else.
Okay, so it really, really helps to, one, know the why, and two, connect things to things that we already know. Because math is always built on the past. It's always built on the past. I mean, every formula, every equation, pretty much in the world, there's only 4 things you can do. You can add something to both sides of the equation. You can subtract something from both sides. You can take both sides of the equation and multiply it by something, or you can take both sides and you divide it by something. That's it. But there's this tendency to keep presenting these new concepts, and they're totally disjointed. So anyway. Memorization of math concepts. Yeah, we asked that. Why? Telling time. Again, this is not going to apply to the teenager mom, but telling time is actually fairly complicated. It involves multiplying by 5, adding the remainder, okay, and then connecting that to the hour thing, okay? And we have kids in the first and second grade now that are being pushed to tell time. I thought this was bizarre enough, okay? But they surprise me. They continue to surprise me. And now we get kids that are in the first or second grade that are being taught what is the quarter hours. So when is it quarter after 12? What kid in first grade knows what a quarter is? Or a fraction, or a half, or
money, so it just
3
get
quarters.
the image of a quarter in their head, and so it's even more confusing.
So it's a completely disjointed concept. They've
quarter is 25, and they're saying it's 15.
Exactly.
Yeah.
Well, they're saying it's 3. A
That's
quarter
true,
is
yeah.
3. A half is 6, and 3/4 is 9. But 3/4 of what? They don't understand that. So this is almost bordering on insanity. It's like, let's see how many kids we can fail and push out of the box now. But for normal telling time, here's as simple as I've been able to make it. We make up 2 clocks, a blue clock and a red clock. And we use 1 through 12 on the first clock, and we put a blue hand on that, a short little blue hand, and we show them just how to read the number of hours. That once it gets past a number, it's that number until it gets to the next number. So between 12 and 1 is 12, between 2 and 3 is 2, between 3 and 4 is 3, between 9 and 10 is 9, okay? And we get that down solid. Then we do the whole minutes thing. And we start by going from 0 to 60, counting by 5s, like the diagram, okay? And then we just go through like repetition, playing the game. We start counting the number of minutes. not by fives, just counting. Just count. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Then we show them the shortcut that they can actually, if they want, multiply by 5 and get the number of minutes. Okay? But we go at their pace. However they're going to do it, we go at their pace. Once they have the way to calculate the minutes down cold, and they know that the run is really a 5, and the 2 is a 10, and 3 is 15, however they do that, then we put the two together. And a lot of kids, they'll get it no problem. But if you try to put these two together first and then give it to them, they're lost. It's too much. It's too complex. Does that make sense? Okay. Money. Okay. So look at the equation for making change for a $6.14 purchase from a $10 bill. There's the mathematical equivalent. Yes, and we're going to break for lunch right now. Because I think, are we at the end of math? Yes. So we're going to finish up. We're going to finish up this math. But notice how complex this is. This is something that really, children, for counting money, they need to understand their times 10s, their times 5s. I've used a system now where I take 3 quarters, 2 dimes, 1 nickel, and 4 pennies. And I say, here's your base. Now, let's start making purchases. We play store. Actually, I can't take credit. A girl with severe sensory integration disorder, bordering on autism, with dyslexia, she's the one that taught me this. So I have to give Jordan credit, where credit is due. But she said, can we play store? Can we play a store game instead of just sitting here and boring counting money? I said, ooh, I like that. So we lined up a whole bunch of little items, pens and pencils and blocks and dragon tears and glass beads and whatnot. And I would give her her little group of money there, and we would start, she would buy things. And I'd say, okay, that's 37 cents. So can you get a quarter, 25, this was after we went through what the money was, the values, and got those down. And then, okay, so can you get 25 cents in 35? Is 25 less than 35? Yes. Okay, put a quarter. What's another quarter? 25 plus 25 is 50. Is that less than 37? No. Okay, so now we go down from quarters, we go down to dimes. 25 plus 10 is 35. Is 35 less than 37? Yes. We go to 2 tens. Is 45 less than 37? No. So we back down to a quarter and 1 dime. Let's add a nickel in. 35 plus 5 is 40. Is 40 less than 37? No. Throw out the nickel. All right, boom, boom, boom. Throw in 2 pennies, 37. We're done. So the point is, break it down into simple steps and make sure that the child is with you. If they're confused, it means you went too fast, you lost them. Whether it's counting money or algebra 2, doesn't matter.